In this video, we're going to look at strings in the programming language Go. In older languages like C, a string would be a pointer to a block of characters. Each character would be 1 byte, representing a single character or letter in the string. That worked well for the English language. Go takes a more modern approach in looking at international character sets. So you'll see here in this program I have some Chinese, French, accent aigu, we have emoticon, Unicode characters, which are referred to as runes in Go, maybe 1 to 4 bytes long each. The other thing that was problematic about the old C-style approach to strings being terminated by placing a 0 byte is that it created a lot of buffer overflow opportunities for attackers. And C strings didn't have stored with them a length because memory was very expensive back then. They didn't want to use additional bytes to store the length of a string. So to compute the length of a string, you would simply walk through bytes until you found a byte whose value is 0. In Go, we are going to store, along with the string, the collection of bytes and the length of the collection of bytes. All right, so we're importing formats so we can print things to the screen and the package strings that will allow us to manipulate. You'll see that UTF-8, which is an encoding of Unicode for strings in many different languages. I've set a variable using the automatic inference of type. So you'll see str1 is a string, and there's a couple different ways that we can specify quotation marks in a string. One is by putting a backslash before the quotation mark. So here we have Martin said, quote, hello, quote. The other way is we can actually begin and end the string with backticks, which on my keyboard is in the top left corner. And then we can actually use quotation marks normally in the string with backticks. So we're declaring a variable here. Martin said hello. We'll print it to the screen. We can index into the string. This will be indexing a byte. It won't be indexing a letter because, as I mentioned, these characters from other languages will be multiple bytes long. So this will represent the byte at position 2. Strings in Go are immutable. You cannot make changes to them. So if I attempt to assign the second byte to the letter X, you'll see when I attempt to build that, we get an error. We cannot assign to str1 2. So I'll go ahead and comment that back out. We can use methods from the package strings. So here we're calling replace. We want to replace within the variable str1 all occurrences of Martin with Frank. Actually, we're only going to do that for one occurrence. Replace would allow me to specify how many of those occurrences we want to replace. I'm going to replace one of them. It will not modify string 1. It will return a new string. I'm going to choose to store that in the variable called string1. This string will no longer have anything referencing it. It can be then collected by the garbage collector in Go. So we'll replace the string, we'll get a new string, we'll have str1 point to that new string, we'll print it out. So we'll have printed Martin said hello. Here it should say Frank said hello. We're doing the string again with a different way of doing quotation marks. I'll show you in printf, we use %s for the string. We can ask for the length of a string. So you'll see here it's the number of bytes. It's not the number of characters, because each character, as I mentioned here, can have 1 to 4 bytes in it. Here we're going to print out, this is a string in Go. Google Translate helped me translate that Chinese. We're going to have the accent aigu from France, the emoticon, the exclamation point. We'll print that out. This for loop here is going to loop over the characters in the string. So we're going to loop over string 3. We get back two things. I is the byte of the character, and R is the rune. And then we'll print out each of those characters. Then we'll print the string as a set of hexadecimal bytes. So I'll build that again without the error. You can see we have Martin said hello. The byte at position 2, we started counting at 0, so 0, 1, 2 is R. We change that to Frank said hello. We print that. We're printing the string Martin said hello with the different quotation marks. You'll note that what's printed to the screen is the same for both stir1 and stir2. It's just two different ways of representing it in the programming language code. We're printing the length of that string, which is 21 characters. We now have this string containing characters from multiple different languages. It prints it out exactly as it appears in the source code. And then we're looping over, so you'll see at position 0, we have a 4-byte character. Position 3, a 3-byte character. Position 3, we have another 3-byte character. Position 6, we have a space that's a 1-byte character. Position 7 and 8, 1-byte characters. All of your English language text in ASCII or ISO Latin 1 is 1 byte long per character. Character 9 is 1 byte. Then each of these Chinese characters is again 3 bytes long. You'll see that the accent aigu is 2 bytes long. That emoticon is a 4-byte character. And then we get to the end. And then we'll see the encoding. So these first 3 bytes were the first character, the second character. That 20 is an ASCII space. G, O, space. Again, a collection of 3-byte characters. We can see the UTF-8 encoding of those. And then eventually terminating with the exclamation point, which is that 21. So that's a quick intro to strings. We'll see more of them later.